Hi Rockridge, this is Mrs. Berger. Today we're going to finalize the new material for Unit 1. Today we're talking about graphing absolute value equations and inequalities. If you remember, we ended last lesson with a dive into Desmos. We played around with some values to see the graph move left, right, up, down, skinny, wide, upside down. And so we're going to delve into the algebra that causes those things to happen a little bit more today, okay? So first, just to remind ourselves what these graphs look like in the first place. The graph of an absolute value function always looks like a V. It is always V-shaped. Okay? It always looks like a V. If you remember from our time in Desmos, that wasn't a terribly good V, but you get my point. It's a perfectly symmetrical V, and the point right here is called the vertex. And the master unshifted version of the absolute value function is y equals absolute value of x. We typically call that a parent function. The parent function of the absolute value looks like this: y equals absolute value of x. And the parent function, the unshifted function of the absolute value graph, has a vertex at 0, 0. Okay, so if you were to graph y equals absolute value of x, it would be centered at 0, 0. Now the general form for an absolute value function that is highlights the shifting that we saw in Desmos looks like this: y equals some factor a, we sometimes call that slope, x minus h, remember h is in charge of your left-right shift, plus k. Sometimes you might hear your Algebra 2 teacher call this HK format, general format. Basically what we want to highlight are three things in this format. Three things you need to look for when you're trying to graph these things by hand. This right here, this K, and I believe in Desmos they called it the letter D, but this outside of the absolute value part, this plus K, is in charge of up-down shifts. Remember, if it's a positive number, it shifts the graph above the x-axis. If it's a negative number, it shifts the graph down below the x-axis. So that's in charge of up-down. The H is in charge of left-right shift. This is in charge of left-right. And this is a really good reference for you to have as you're doing your homework. So look back on this to remind yourself what's in charge of what. The only tricky part here is we know that if k is positive, we moved up above the axis, and if k is negative, we move below the axis. Kind of the opposite happens in here. The standard format that we're looking at is always x minus h. So if this inside is x minus 2, just this part is in charge of the shift and would go right. If this was x plus 2, you'd be going left because it would basically be a negative negative. And we'll see a couple of those in the examples, but I just want to really, really highlight that because that's one of the more confusing parts of this. And then finally, this guy right here is in charge of, and I just call it skinny or widening or any upside down flips. Okay, if this number right here is not an invisible 1, if it's something else, if it's something larger than 1, you're going to make it a skinny V. If it's something less than 1, like a fraction, you're going to widen it. If it's negative, you're going to be flipping that V upside down. Okay, so always come back to this little reference for yourself to realize what's happening in your graphing. So let's dive right into that graphing with our first example here. So if we look here at standard form, this is your A, this is your H, this is your K. Obviously we don't have a K out here, right? We have a little invisible plus 0. And we also have an invisible 1 out here. So as we're looking at this and we go back to our little reference point, since there's nothing here, there's no up-down shift. So if our parent graph usually sits at 0, 0, that's not going to move up or down. It's going to stay right here on this level. So that's the up-down. That's taken care of. There is no up-down. There is a left-right shift, though. And remember, the standard form is x minus the right shift. So since this is x minus 3, we're going to go right 3. 1, 2, 3. So our new location of our vertex Instead of that v having the pointy part at 0, 0, it now has it at 3, 0. And then if we need to go from here to build our v, we look here to see what the quote-unquote slope is. This is basically a 1 over 1, or what we typically see in our parent function of it, up 1, up 1, up 1 over 1, up 1 over 1. And then for the other side of the v, up 1, back 1, up 1, back 1. And you can draw the best you can on a line through that to create your v. It needs to be a symmetric v. Okay? Now, AOS, axis of symmetry. Hopefully you remember what that means. Axis of symmetry means the invisible line that would cut this perfectly in half. Okay, so where would that line sit? That line would, in order to cut this perfectly in half, that line would have to cut straight through here. So here's this invisible line that we're talking about called the axis of symmetry. What would be the equation of that line? What would be the equation of that axis? We know it's a vertical line, right? It's not a horizontal line. It's a vertical line. It doesn't have any slope. It's a vertical line. And so what was the format of an equation of a vertical line? Do you remember from Algebra 1? Hopefully you remember that that had the form x equals. And in this case, x equals 3 would be the vertical line, the equation of the vertical line that would cut this in half. Now, make sure that you don't give us just a 3 as an answer for this, okay? The axis of symmetry is never just a number. An axis of symmetry is the equation of this invisible line. It's the whole equation of the line, okay? So make sure you tell us x equals 3 would be the axis of symmetry that would cut that in half. All right, and when we ask for direction, we're just saying, is this v pointing up or is it upside down, pointing down? And so this one is pointing up. Let's take a look at another example. Example 2. This one does have an up-down shift. So if we started at our typical starting point for the parent of 0, 0, we would need to move up 1, 2, 3, 4. And then if we look in here, we do not have any left-right shift. So we just shift up 4, and that's our new vertex of our absolute value graph. So we can immediately document 0, 4 as the vertex. Now let's look over here. Once again, we have just an invisible 1. So our factor, our quote-unquote slope of this is once again up 1 over 1, up 1 over 1, up 1 over 1. And then for the other side of the v, up 1, back 1, up 1, back 1, up 1, back 1. So we can go ahead and graph that as best we can through those lines. Now we need to think about what is the axis of symmetry. What is the invisible line that would cut this in half if it existed in real life? What would cut this straight in half? We know that the axis of symmetry always has an x equals format. And in this case, x equals 0 would be the equation of the line cutting that in half. The direction of this graph is up. If any of that went too fast for you, go ahead and pause the video and rewind. Alright, now let's step it up a little bit. Here we don't have an equals. We've got to take care of the fact that this is less than. We've got an invisible little -1 going on here, so we've got something happening with the a factor. We've got an up-down shift and a left-right shift. So we're going to need to take care of all of that. There are a couple places some people like to start. I like to start with the up-down shift. It's the most straightforward. It kind of keeps me grounded. You can start with left-right if you need to, but I'm going to start with the up-down. So again, our parent function starts at 0, 0. This means I go up 1. So now I'm up 1. This means I go right 3, because remember, standard form is x minus the h, and so I'm taking the 3 as is, so I go right 1, 2, 3. There's the new vertex. My new vertex is at the coordinate 3, 1. Now I'm going to draw my v, and notice that I have this -1 as my quote-unquote slope. So I'm going to be going down 1 over 1, down 1 over 1, down 1, back 1, down 1, back 1, to create an upside down v. Alright, so that is what I would have created if this symbol right here was an equals, right? Just like we did over here. We built nice solid lines, And once we were done drawing the solid lines for the v, we were finished. We don't have that here. We have a less than. So hopefully you can recall from your days of less than, greater than, when you were doing the shading work for your linear equations in Algebra 1. Hopefully you recall that if you have a less than, you shade below. If you have a greater than, you shade above the function. If you have a less than equal to, you shade below and you have a solid line. If you shade above, if you have a greater than equal to, you shade above with a solid line. Do you remember what you did if you had less than but not equal to? That meant you had dashed lines. Okay, so these guys are dashed lines. Because remember, you don't have the bar underneath. Hopefully you remember this from Algebra 1. So let's go back up and see the scenario that we have in problem 3. Problem 3 is less than but not equal to. So if I'm less than but not equal to, I should have put a dashed line. So I'm just going to sort of fake that here with my eraser. I'm going to turn this into a dashed line. If you drew this originally as a dash, that's fine. So I'm going to make that a dashed line because I'm less than but not equal to. Then I'm going to take a look at my shading. What's my shading situation? I'm less than, so I shade below. I shade below for less than. And on your quizzes and tests, if this is plenty of shading. You do not need to black out the entire graph. As long as you can indicate that you're shading below, you should be good. And then once again, if we're talking about axis of symmetry, the line, the invisible line that would cut this in half, that's going to go straight down the middle here. The equation of that line is x equal 3. The direction of this particular absolute value graph is down because we flipped it upside down. Okay, let's take a look at the next problem. Once again, inequality. So from here on out, we're talking inequality. So all of these are going to need some shading. So y greater than absolute value of x plus 4. Once again, we have this invisible little plus 0, so there's no up-down shift. So let's start at 0, 0. We're not going up or down. We are going left, right. And let's recall, standard form is of absolute value is x minus h. So we need to think of this as x minus a negative 4. That's what's going on in here. X minus a minus is what happened to make this x plus 4. So that must mean instead of going right 4, I go back 4. Okay? 1, 2, 3, 4. And I'm not going up or down. And then from a slope perspective, I don't have anything but a regular old positive 1 here. So I'm just going to do my up 1 over 1, up 1 over 1, up 1, back 1, up 1, back 1. And I'm going to draw that v. Then I'm going to look and say, this wasn't an equal sign, this was a greater than sign. So greater than but not equal to means I should have a dashed line here. So I will make this a dashed line. And greater than from a shading perspective means I need to shade above. So go ahead and shade above the best you can. Anything like that indicates to me you know what you're doing. So this is the graph of y is greater than the absolute value of x plus 4. We shifted it back 4. The vertex ended up on negative 4, 0. The axis of symmetry, if it existed, would cut straight through here. So the equation of that line, that vertical line, would be x equal negative 4. And the direction of the graph is up. Let's take a look at number 5. Once again, there's no up-down shift. There's just a left-right shift. For this guy, it's handing it to us in x minus h format. So we can go ahead and say, all right, you're starting at 0. Go right 4, 1, 2, 3, 4. My new vertex is sitting at 4, 0. Now from a slope perspective, we don't have an invisible 1 anymore. We have this 2 over 1 sitting here, this slope of 2 over 1. So that means I make my v into an up 2 over 1, up 2 over 1, up 2 back 1, up 2 back 1. And I draw my v. It's not negative, so it's pointing up just like the others. Now, this is not an equal sign. This is a less than sign. And it's a less than and not equal to. So I need to come back and dash this. If you originally dashed it to begin with, that's fine. Good for you. So that should be a dashed. It's less than but not equal to. And from a shading perspective, I'm less than this graph, so I'm shading below it. And again, you don't need to black out the whole graph. You just need to indicate to me that you understand shading below is where my solutions to this are going to be found. All the less than this graph are the solutions to this problem. The invisible axis of symmetry that would cut this in half cuts right down through here. Hopefully you've noticed by now that your axis of symmetry is simply the line x equal the x-coordinate of my vertex. You can bank on that. And the direction of this graph is up. If I went too fast on any of these, please pause the video, go back and replay that until you understand. Alright, y is less than or equal to this old thing. Now, please recall, our format, our general format for this is a times the absolute value of x minus h plus k. Notice there's nothing in front of this x. If you are going to use this form to graph your absolute values, there may not be anything here if you want to pull the h and k for your vertex. Okay? Vertex form on this. In this problem, somebody snuck a little 2 in here, and that's problematic. You may not pull this off and say the vertex is sitting at 4, negative 3. You may not pull the vertex until there's nothing in front of the x. And we've got a neat little trick that we can use to pull that out. We can actually treat this kind of like a GCF problem that we had in Algebra 1. We can factor out this greatest common factor of a 2 from both of those. It works very similar to if those were parentheses. So we're going to factor out that 2. So what that would look like is we'd say, all right, you're still y is less than or equal to 1/2. And you're going to pull out, you're going to factor out a 2. Okay? So you're going to factor out a 2, and you're going to leave behind x minus 2. Okay? So you basically divided this term by 2 and this term by 2, and that's why you were allowed to pull out the 2. And then this minus 3 has nothing to do with all that business. He's sitting here by himself. So now that you have, notice now that we have within these absolute value bars an x all by his lonesome, nothing's glued to the front of him, now we may pull the vertex off of this format. Now we can say, if you're starting at 0, 0, you shift down 3, 1, 2, 3, oh, sorry, 1, 2, 3, there we go, and right 2, 1, 2. To say your vertex is now at 2, negative 3. Now let's take a look at the slope of this. Out here, this whole thing needs to be combined into your slope. And what's 1/2 times 2? That's just 1, right? That's just 1 over 1. So your slope has now become 1 over 1, up 1 over 1, up 1 over, and it's a positive. So it's opening up. Let's go ahead and draw that in. And again, we could not pull this vertex off until we factored out this 2. This is a very, very fun problem for Algebra 2 teachers around the world. We love making you factor out that 2, so make sure you're cautioned, look for that every time. Alright, let's take a look at our dashed solid situation and our shading situation. So again, we don't have an equals, we have a less than equal. So less than equal means I can leave this solid, because this little equal sign's here. And less than equal means I'll be shading below. So keep it solid and shade below is what that less than equal to means. Once again, I can say my axis of symmetry is x equal to the x-coordinate of my vertex. And the direction of this absolute value graph is pointing up. Now, if you'd like to pause the video and attempt these now you tries, I think that'd be a great idea to see if these concepts are sticking with you. So I would highly recommend that. I will run through a couple of these to kind of get some of the main points down. If you don't get through all of these with me here on the video, check your answers with your teacher. Okay. So if I'm looking at this one, now that you've paused the video and attempted it for yourself, you're now back checking your work. You should have looked at this and said, all right, I've got a down 4, right 3 going on. So I've got a down 1, 2, 3, 4, right 2, 1, 2. So my new vertex is right there. It says label the vertex. I'm going to label my vertex 2, comma, negative 4. I'm going to look here and I see that there's just an invisible 1 and there's an equals sign. So I can make my up 1 over 1 graph and I can draw it with a solid line. So that should be your graph. Better than that, hopefully. There we go. And your axis of symmetry, if you were going to draw that in, would be this line right here. This vertical line, hopefully straighter than the one I just drew. Sorry about that. Your axis of symmetry is x equal 2, drawn like that. On B, you have a shading scenario. So don't forget that. When you do all this work of finding the vertex, sometimes people forget to shade. So we've got a up 3, right 2 situation. And you can do either one of those first. So over 2, up 3 to find your new vertex. Our quote-unquote slope is a negative 2. So that means I'm going down 2 over 1, down 2 over 1. Because I'm now, not only am I upside down, but I'm also skinnier. And this symbol right here means I'm greater than equal to. That means I get to keep the pink lines solid. And I get to shade above since this is greater than. So I shade above for greater than. Labeling the vertex, I can just kind of point to it and I say the vertex is sitting at 2, comma 3. And if I want to draw the axis of symmetry, I would draw that as this line, this vertical line right here of x equal 2. Letter C, or part C, notice that I've got this pesky number glued to the front of my x. That's a no-no. I may not look here and say, oh, there's nothing out here, so I'm not going up or down. I'm just going right 8. No, you're not. You may not shift the graph right 8 because this 4 is sitting here muddying the waters. We have to quote-unquote factor that 4 out if we're going to use our skills in shifting the graph. So let's do that. Y, you are less than negative 1/2. I'm going to factor out this 4, so shove you outside the absolute value. And when I leave behind, I divide this by 4 and leave behind an x. I divide this by 4, I leave behind a minus 2. And there was nothing out here. So, and I'll draw this just so we can remember. There's no up-down shift because there's nothing hanging out outside here. There is a right 2 shift. So I'm going right 2, but I'm not going up or down. So my new vertex is at 2, comma 0. Now let's look here. What's going on with the quote-unquote slope of this thing? Negative 1/2 times 4. Well, half of 4 is 2, and I need to negatize it. So my new a term is negative 2. So that means I got to go down 2 over 1, down 2 over 1. Now, if you forget to do this, if you forget to pull this 4 out and you start graphing, your graph will be way too far to the right and it'll be really, really obvious to your teacher, okay? So it's hard to hide a mistake like forgetting to take out the term in front of the x, so make sure you do that. In a minute, I'm going to show you how to check this on your calculator. Now, this graph is upside down. It's got a down 2 over 1 kind of quote-unquote slope to it. It was shifted right. But let's not forget, we're dealing with a less than. If we're dealing with a less than, we need to go back and make this a dashed line. And I tell my students, if you have to go back and dash this, and you're not real sure if it's real clear on your test that it's dashed, just tell us, hey, teacher, this is dashed. Okay? If for whatever reason your pencil marks or your erasers or you're fixing your work, just tell us it's dashed or tell us it's solid if you don't think it's clear. Alright, so this is dashed, and we are less than, so we are shading below. See, even as I'm shading here, I'm kind of muddying the waters. It almost looks like I did a solid line here. It's probably a great idea if after you're done shading, if it's not real clear, just make a note to us. Hey, I mean for that to be dashed. And you'll get full credit. Alright, D is another great one. I'm going to let you guys do this on your own. Once again, we've got this 15 that needed to be factored out, okay? The key is online. If you've done this work for yourself, go ahead and grab that key and see if your graph matches. But I do want to pull up the calculator at this point and show you. So let me just go ahead and graph one of the examples we just did. Let's also get familiar with where things are, right? So if you want to graph something in y equals format, you'll go ahead and click this button here, y equals, and that'll pull up, and you can graph all kinds of things. We're just going to graph one thing. We're just going to graph the y1 here first. And we're going to graph y1, and I need to graph the absolute value of something. So I'm not even going to look at an example we've done. I'm just going to make one up here. I want to graph -2, so I go -2 times the absolute value. And where do I find absolute value? Hopefully your teacher told you to find absolute value, you go to this math button here, right here, math button. Toggle over to the num part of that menu, num, and there's your absolute value choice, choice 1. Okay, and that'll give you your absolute value bars, and you can fill that into your heart's content. Y equals -2 times the absolute value. Let's do absolute value x plus 1. Why not? And then on the outside, I want to do an up-down shift. So let me toggle outside of my absolute value bars, and I want to shift. Let me go down, I don't know, 4. Let's go down 4. Let's just see what this looks like. Okay? And again, if you don't remember, if you wanted to take that note, math, num, abs. That's how you get that. Okay? Now, I have apparently played around with this equals sign. I've gone up here and I said, you know what, I'm going to do a greater than to show the shading. So let me show you what that looks like. You can actually make your graph shade for you if you bother. So look at that. It graphed a V. It's got, I know it doesn't show on my screen here terribly well, but on your calculator it'll show these hash marks a little bit better. It moved left 1, down 4, which is exactly what we were expecting. And it shaded above because I programmed this to be greater than. See this little symbol right there? That's greater than. And you would just toggle to the left to play with greater than, less than. Let's wipe that out and show you what it would look like with just a regular old equals. This symbol means I'm just doing an equals. Let's do a math, num, abs, absolute value of x plus 1, toggle out, plus 3. Okay, so this is supposed to be a solid line because it's just plain old equals. And I'm expecting the vertex to be at -1, 3. So let's see if that happens. Sure enough, -1, 3. It's a solid line because I programmed it to be just y equals instead of y greater than. So you're good to go on that one. Now, how about those pesky ones where somebody glued something to the x? Let's go see how that would work. So let's change this to have a term in front of the x. How about 2x minus 1? Why not? Okay. So now we have a 2x minus 1. Actually, no, that's not a good example. Let's do 2x minus 4. 2x minus 4. So if you were doing this by hand, you would know, oh, wait, I can't just, shift right 4 up 3. I've got a problem. I've got to mess with this 2. So you would factor this 2 out, causing this to be 4 divided by 2, which is 2. So your new vertex would be 2, 3. Let's watch the calculator do that calculation for us. By leaving that 2x in there and not factoring it out, your calculator's smart enough to say, oh, I know what to do with that. I'm supposed to take a 2 out. So your vertex should be at 2, 3. And sure enough, 1, 2, 1, 2, 3. There's my new vertex. Also, it factored out that 2 and it made it skinny. So hopefully you notice that this is a little skinnier than usual. It's an up 2 over 1 instead of an up 1 over 1. Okay? So just wanted to get you familiar with the keys. You should have time to check your work. So if you graph something by hand on the test, you should be able to check it on the calculator or vice versa. Make sure you get familiar with that. The last concept we want to talk about today is going in the reverse direction. Instead of being given the algebra and coming up with the graph, we want to give you the graph and come up with the algebra. Some people think this is easier, some people think it's harder. It's just a little bit different. What I love to do for these is to look at this graph and say, wait a second, it's a V. I know what a V is. That's an absolute value graph. So I know a lot of information about my algebraic equation already. I know it's got to be y something. And I know that's got to be absolute value of x something. So I kind of make myself a little skeleton. That's what I call it. I'm going to fill in all the muscles and stuff of the skeleton based on the information I pull off the graph. But I know there's got to be a y here. I know there's got to be an absolute value of x something there. Now, am I going to have a y equals, a y less than, a y greater than, a y less than equal to? That's pretty easy to jump to, because I'm looking at a solid line with no shading. Solid line, no shading, this has got to be y equals something. So that's that part filled in. Then I'm like, wait a second, where's this vertex sitting? Because that could fill in a lot of information for me. My vertex is sitting at 1, 2, 3, comma, 1, 2, 3, 4, 5. And I highly recommend you write the vertex before coming down here to fill in. So my vertex is at 3, comma 5, which must mean I moved up 5, and I moved right 3. And remember the format again, it's x minus h. So I moved right 3, x minus 3. Now the final thing I look for is whether or not I need to mess with this slope. This guy looks like he's an up 1 over 1, up 1 over 1 kind of guy. So I don't need to put anything here. For our notes, I'm going to go ahead and remind you. Let's go ahead and say that there's a positive 1 there. You don't have to do that for a test, but I do always want to encourage you. You need to look for that information off the graph just to be sure. So once again, you need to check for whether it's equal to or an inequality, what the quote-unquote slope is, what the right-left shift is, and what the up-down shift is. Everything else should be the same. All the other stuff you should already have ready to go as your skeleton. So let's take a look at this last example here. We know we've got a y. We know we've got absolute value. We know we've got an x. We just need to fill in the rest. So let's take a look at what the rest is. Let's first look at, what do we have? Equality, inequality, what do we got going on here? I see shading happening. So because there's shading happening, I know there's not an equals. I know it's not an equation. I know it's an inequality. And I see there's shading above. So as soon as I see shading above, I start thinking, all right, I've got a greater than situation. Y is greater than. And I see solid lines. Solid lines, I've got a greater than equal to going on here. So that's the first thing I needed to fill in. Let's fill in the up-down situation and the left-right situation. Up-down, what's going on? Did I shift up or down when I was starting at 0, 0? Looks like I went down 1, 2, 3, 4. If I went down 4, this must be a negative 4. Negative 4. Did I go right or left? Looks like I went left. It looks like I went left 1, 2. If I went left, this must be a positive 3. If it helps, you can remember that's x minus a minus 3. Remember, I highly encourage you to pull the vertex off and write it up here, right? So the vertex is negative 3, comma, negative 4. If the vertex is, oh, did I write 2? Sorry. My apologies, negative 2. You're probably screaming at me over the video, aren't you? It's a 2. It's a 2. Sorry about that. You looked at this graph and you said, negative 2, comma, negative 4 is my vertex. If negative 2, negative 4 is your vertex, the negative 4 pops down here as is. The negative 2 comes in here as an x plus 2 for this reason. That's a pretty difficult concept to learn at this stage, so pause and rewind as many times as you need to make sure you get this right on the test. Alright, last little blue line to fill in of our skeleton. Slope. Looks like this guy is an up 1 over 1, up 1 over 1. Yeah, it's pretty consistent. Up 1 over 1, up 1 over 1. Doesn't look like he's straying at any point. So I would say this is an up 1 over 1. This is a positive 1 slope. You do not have to write this in if it's a 1. I just want you to remind you to check for that on your test. Okay. Alright, you have plenty of homework to practice these concepts. You will also have extra problems in class on review day, so I highly encourage you to play with this, play with Desmos, play with your graphing calculator until you're comfortable with the translations of the absolute value graphs. And good luck!